Sergei Paltsev. He's a professor at MIT. He has been active in questioning the panel earlier. Now you are in the panel, so now probably people can ask questions to you. But can you say something about the US situation? We have now heard during the day that you have a lot of positive signals, actually, in your country in that way that you have now been a net exporter of natural gas, you know, and LNG, and you have been switching from coal to gas to a large extent, that you have reduced your CO2 emissions as well. Is there something you would say about this general situation? And Trude also mentioned that there are some incentives for CO2 sequestration. I guess it has something to do with EOR, or isn't it? Is it just for sequestration? Can you explain that for us?
Yeah, gladly. Indeed, the situation with natural gas in the United States has changed dramatically. As many of you know, like 10 years ago, everybody was thinking that, well, it will be a lot of imports which are going to be going to the United States. Well, now the situation has flipped the opposite way. So just to give you some perspective, as many of you know, well, Norway is the #3 exporter. And the exports of Norway are around 120 BCMs per year. Just several years ago, US had very, very tiny LNG capacity from the previous area in Alaska going to Japan. But in terms of the serious LNG, we just started from the new Sabine Pass Cheniere terminal. And to give you the scale by how much we are going to increase the capacity of our LNG, by 2022, if all projects are on schedule, it will be more than 90 BCM of export capacity. Exactly. So, well, you can see that that is going to affect the markets in quite a substantial way. In addition to that, well, you know that in Australia, there is another wave of LNG about the same capacity, so another 100. So then there is a Qatar, which currently has 100. And they recently lifted the moratorium, and so it will be very different situation, which is in many cases inspired by the shale gas revolution. Also, the current drop in prices, so a lot of people are saying, oh, look, the LNG prices have went dramatically. Well, that's also due to another development, due to, well, in part, in development in the tight oil market development, which makes some players on the oil market uneasy. As a result, it was some decisions which have been made, which resulted in dramatic decrease in oil prices. And because a lot of gas trade is tied to oil prices, so the gas prices also reduced due to that phenomenon. So in general, US, and if you sometimes can read quite interesting statements, so our Secretary of Energy said that, well, the US is leading in terms of the emission reductions. So, well, which is kind of a surprising statement. But indeed, if you will find the right base year and the right period of time due to switching from coal to gas, that's indeed true. And that shows you the power of this resource in the initial reduction in terms of the gas. Right. Now, we already have seen several projections from different agencies which show quite bright picture for natural gas into the future. Well, the bigger question, what about the long term? So what about after 2040, which is a period of projections from IEA? And this is where the thing which you have mentioned about the CCS is starting playing the role. In 2011, we have issued at MIT the study which is called Future of Natural Gas, where we said that natural gas is a bridge fuel. Yes. Well, how far into the future that bridge is. And, well, that is going to depend on that technology, which is CCS. In terms of the current support, the recent tax reform, which just passed, indeed has a support for CCS projects in the power sector on the magnitude of $50 per ton of CO2. For industrial applications, it's $35 per ton of CO2, which in power sector, probably that's not going to cover the full cost, but it's a substantial incentive to consider that. And speaking of the need for CCS and how far the natural gas bridge is going to be into the future, I very like your statement that, well, we need to not just talk to specialists, but we need to talk to others and show the value. And we are in the perfect place to do that because, well, Norway has the perfect opportunity to show the value to the whole world. If that project is successful, if you can show, look, we can do it, we can be on budget, and it's doable, well, that's the best way to communicate that CCS indeed is going to have the future.
Very good. It's very supportive to Trude and to the Norwegian politicians. The last person in the panel, Jean-André, you are a researcher and work in research and development in Air Liquide. And you called yourself as a hydrogen man. What do you mean by that?
So I would say first that hydrogen is not science fiction. Title started to mention hydrogen as a potential future, but Air Liquide operates across the world several steam methane reformer units, plus hydrogen pipelines and several thousands of miles and kilometers in Benelux, in the Gulf Coast, in the US. So we have, I would say, quite a significant experience in operating safely because it's controlled and safe to operate hydrogen. First, and second, it's used actually currently, for example, in the industry by refineries to remove sulfur, so to match environmental standards. So it's already beneficial for the environment. But what we like to do now I would say to go beyond this current use is really to match this environmental goals, for matching this 2-degree ambition. And we have, as a company, formed a consortium called the Hydrogen Council, with 18 other companies, among Statoil. Among of them, Statoil is a member of this consortium. And this, I would say, consortium try to promote the hydrogen as a real environmental solution. And the vision, actually, you mentioned beyond 2040. It's a vision has been laid out for 2050. One pathway to match this ambition is to reach a very high level of hydrogen. The number are roughly 18% of the final energy demand, and 6 gigatons of CO2. So it's really, I would say, a long-term effort that can be pushed with all the stakeholders along the value chain. Of course, we need to go step by step. Some regions are more, I would say, politically friendly than others. We have South Korea, Japan, Germany, and California that are really, I would say, early adopters because they have plans. They have national plans for hydrogen. Japan, for example, they have this plan for 1,000 filling stations in Japan by 2025, 400 filling stations for Germany by 2023. So it does exist. It's, I would say, ramping up step by step, and it's safe. One of the, I would say, key transformation is in the transportation sector. It has been mentioned before. It's one of the main challenges to decarbonize transportation sector. Sure. And fuel cell electrical vehicles are going to be very complementary to battery electrical vehicle. You have the battery electrical vehicle on one side, which is for the short range you can reach now 500 kilometers. You have, I would say, quite flexible use within the cities. And for, I would say, small load. On the other side, you have the fuel cell electrical vehicles that are more for heavy load, trucks, trains, it has been mentioned before, and for long range. For example, currently you have a taxi fleet in Paris that is running on hydrogen fuel cell electrical vehicle, and they need this long range capability and to refill fast. So it's really complementary.
Right. Before addressing to the scientific persons here, there was something I was wondering a little bit about because Robert, you presented in UK that you have done some political, you call it economy, so that you put some money so that you have the switch from coal to gas, and you say that it is also a flexibility. The gas is the flexibility in the system, if I understand you correctly. So you have a power plant that has the flexibility. When you look at Europe, they report the opposite in many ways. It's not competitive to have the flexibility by gas, many people say. And Johannes, you showed this load factor, which is probably the explanation for that in a way. How come that you can do that in UK, but you cannot do it in Europe?
Okay, so that's a good question. I'm sorry if I didn't explain that clearly. So I was just reporting the price at which coal to gas switching occurs in the power sector, and so just in terms of the comparison of cost competitiveness, plus the cost of the carbon bill, which is associated with a particular carbon price. And so it's just a comparison in terms of the total cost of electricity via a coal-fired power plant compared to a gas-fired power plant. And most of the, I mean, as I said, the precise numbers vary by plant and by country. But in the case of the UK, we've seen, so the carbon price floor is set currently in dollars, roughly at $25 a ton of CO2. And we've seen that has in fact induced significant switching within the power sector. I should add that, of course, the carbon price floor is not the only policy instrument in operation. So we also have a capacity market, which was mentioned. There are also some performance standards that are being used. And of course, another thing that is important is just the market price of coal versus the market price of gas, which itself is fluctuating. I can't sort of cite a particular study, but I think those coal to gas switching prices across Europe should be in a similar kind of ballpark. I think that the numbers in Asia tend to be a little bit higher.
Okay. Is there any questions from the experts around the table here? Or have you been sleeping now? I don't see anything, actually. What's happening? Oscar, you have to start.
Thank you. One of the topics that we seem to come back to during the day is carbon capture and storage. And it's both something that is slightly controversial, but also something that shows up in most of the climate scenarios as a part of the solution. It's difficult to reach the 2-degree target and 1.5-degree target without having carbon capture and storage in place. First of all, because you can use carbon capture and storage and natural gas as a flexibility fuel, but second of all, because you need to provide, for example, clean hydrogen for the heating system, and also because you need to have negative emissions in the second part of the century, and you need to capture CO2 from, for example, bioenergy. And at that, in this situation, it's quite worrying to see, of course, that very few countries are able to or willing to invest in demonstration chains and full-scale chains. And we did a study for the Zero Emission Platform a couple of years back, looking at the, what you could call transition measures, support measures for early implementation of carbon capture and storage. And one of the findings was that some of the early mechanisms probably were wrongly designed if you wanted to support carbon capture and storage, because it was mainly designed as capital grants, which would mean you get some support to build the carbon capture and storage facility, but no support to operate it. So basically, it wouldn't be dispatched. It wouldn't be part of the energy mix, even if it was there. And that points to something very interesting, I think, to address over the next months, as we are doing in Norway, and years for Europe. How should you really design this support mechanism in terms of similar approaches that you would have, for example, for renewables? First of all, maybe operational support. Second of all, a guaranteed type of market access. Maybe not market access guaranteed for energy, but some kind of flexibility deliverables. And it will be very interesting to hear both from, well, from all the panel participants, what kind of support measures would be needed, but also in particular from Robert. How are you remunerating flexibility in the UK in order to support this kind of initiatives?
Robert, or is it Trude? Are you?
I think you have some very valid points. I definitely think we have to work harder on how to finance it and what kind of incentives you would need. So what we are currently looking into is both to support the investment and also the operational costs. And then it is, of course, negotiating between the state and the private sector, how to share the costs and to share the risks. Why haven't we succeeded in the past? I think you need to look into a whole range of incentives. And I think the example from the US, I'm surprised not more people have picked up on that one, because it's really important. $50 per ton if you do CO2 storage. And they have also opened up now for industry emissions, and they don't have the ceiling that they used to have in the earlier tax bill. So I believe we'll see many more CCS projects in the US than we have in the past. And to be honest, that's where you find the most CCS plants already. So they have been following this path. What is different, what we're trying to do in Norway, is to think about infrastructure development. I think that is also important. So I think international collaboration, sharing the experience that we gain from using different incentives and different setups and how you think about infrastructure development, I think is what we have to do. And then I definitely think not look behind, but look ahead. We cannot just use the not very successful examples from the past to not deliver on the Paris Agreement target. It's too important to fail in the future.
Sure. Great. I think we turn to the public.
Okay, so we have a couple of questions in the audience
Help us a
who
little
we
bit.
haven't heard from before, Johan. So let's start over here. Who is it? Okay, here we go. Get your caching hands ready. Please stand up and tell us who you are.
Hello, I'm Sebastian Stinne. I'm a guest researcher at NTNU from Germany. And I was missing 2 points in terms of gas, and that's carbon capture and utilization, so not only storage of CO2. And on the other hand, especially if you're looking at a further future, power to gas and not only hydrogen generated from natural gas. What do you think about these 2 things?
Thank you, Sebastian.
I can take an initial.
Sergey.
So we have looked at these issues. Indeed, there is several opportunities where you can do utilization. So like in cement, well, you can even do some conversion to fuels like methanol and other things. The scale is not as great. So if you're really talking about the cleaning up the whole energy system, there is a certain niche for those applications, but not as much. At the same time, we are talking about the CCS, and usually we are thinking about CCS on the power sector. I want to stress that it's even more important to look at the CCS on the industrial side, and I'm very glad that I think one of the project is cement factory. So if you're going to take a look at the cement industry, so the emissions from the cement industry, just for the cement industry, it's about 8% of the total global CO2 emissions. So about 4% from the process, 4% from the fuels. But if you are going to have a solution for that, well, you're already solving at least some part of the problem. But again, that's not going to be enough if you're talking about the whole value chain and the whole energy system. But yeah, there is obviously we should be doing as much as we can.
And Jean-André?
Yep. Just to complement on the CCU, we have some application for food-grade CO2. As you know, you have CO2 in Coke, for example, and in some beers as well. So we have one example in the SMR in France. That was just to complement. That's a type of CCU that can be developed. On the second point, I think on the power to gas, I think it's quite interesting to see the complementarity between the electrolysis versus the CCS plus reforming of natural gas. Currently, clearly, the cost of electrolysis are a bit higher, definitely. We expect that the curve of the cost for electrolysis are going to go down, but definitely natural gas reforming plus CCS is going to be the first phase that can really trigger the hydrogen economy, and step by step we can expect that the electrolysis is going to add a more greener touch to this mix.
Okay, so there's a question here. There we go. Ready?
I'm Karen Lindberg. I'm an associate professor at the NTNU.
A bit louder, please.
Okay.
Go for it.
I just would like to recall on the first session this morning where Gunnar Lodeler had a speech on how to reach the zero sustainable society. And he stressed again and again that the power production needs to be zero emission. And I have the impression that the discussion here in the panel with using natural gas as instead of coal is a blind alley. And this was also stressed by Gunnar several times. And the reason why we need CCS is CCS for biofuels in order to reach the negative emissions. So I would like to have your comment on that.
Anyone in the audience? Johannes? Yeah.
I think that's an important point, and that's something that I try to highlight also in my talk on the EU, is that the primary climate policy risk is actually in the power sector. That's one of the sectors that is the easiest to decarbonize, and that's also the reason why actually, by 2040 in the EU, in the power generation sector, gas is a high carbon fuel. And that's the underlying reason for the load factor of the gas plants dropping so significantly, is really these gas plants, they're not there to produce baseload or mid-load electricity. They're there to provide a system function. But then probably a lot also depends on what the time frame is that you're looking at. And like if you're looking at 2040, you also need to be realistic about how quickly you can shift away from coal in some places. If we look at the enormous coal fleets in India or in China, where these countries also face very strongly growing energy demand, you need to deploy all potential options to reduce CO2 as quickly as possible. And here, I think this is another sort of transition role for gas. And again, in these systems, at a certain point, gas becomes a high carbon fuel. But when this point exactly is, that's up for research and up for debate.
Additional comments from the panel?
Yeah, I think I would like to to give a warning, actually. When we talk about communicating to the public, we have to simplify the issue of CCS. So don't make the argument that you shouldn't use it for this or that, and because we need all the solutions, all the tools in the toolbox have to be applied. And for industry emissions, we don't have an alternative. And I agree, bio-CCS is very important, and in fact, the waste-to-energy plant that we are studying would give its biofuel by 60%. But don't make it too complicated for the public to understand the issue. It's about reducing CO2 emission to the atmosphere, and we have to use all the tools in the toolbox.
Richard, do you have something?
Yeah, I mean, I think it's a good question. I would echo Johannes's comments. I was very much giving a sort of shorter-term perspective on what's going on in terms of gas and carbon pricing, and it seems to me that, at least in the European context, the putting the appropriate policy framework in place to induce switching from coal to gas is a way to, at least in the short term, bring emissions down by significant amounts at a relatively low cost. And but I agree, over the longer term, definitely, there are other things that need to be done, which currently are less predictable. So I think going for what is a relatively sort of quick win seems to me to be a sensible initial action within that longer term strategy.
Good. And we turn to Ruud Egging from NTNU.
Thank you. It was on already, okay. I have two questions, one a bit more technical and one a bit more general, I hope. Johannes, in the pictures you showed us, we see on the one hand possible reduction of average gas usage by only 25%, but we see that the load factors of the gas turbines nosedive. I think it went from 50-60% to 15%. So if the gas turbines nosedive, and but in the system it's only 25%, where's the difference?
I think maybe would need to look into the numbers in detail, but I think maybe the answer is a misconception in the sense that gas isn't only a power generation fuel. I think the key point that I always try to stress is when we think of gas, we shouldn't only think of gas in power. The biggest sector actually in the European Union that uses gas is the building sector. And I think the second largest is industry, and then only comes power. And there are systems where it's different, where gas is primarily a power generation fuel. But then I think gas is very versatile, can be used in various different things. And the fact that the gas use in households and in industry remains relatively resilient may actually be the answer to your question.
The other question I have has to do with the economics, because on the one hand we have a gas-fired power generation, which is very flexible and it's low capital intensive, so it can be very responsive to prices in the market, and it ramps up quickly, so flexible, easy, and basically designed to not be used so many hours per year. On the one hand we have CCS, which is quite capital intensive, and we would like to use it for many hours per year to earn back the capital. Mm-hmm. So the combination of gas and CCS seems to go a bit counter in the economics. The gas itself is there because it's flexible and really price responsive, but it seems that CCS would prefer to be used in a baseload kind of setting. Mm-hmm. So where the economics go a bit counter each other, and any reflections on that?
To me as well, or?
Sure.
Yeah. Yep. So perhaps the first part of the answer is that actually in our sustainable development scenario, CCS doesn't play an enormous role in Europe, where most of the flexibility needs are. That has to do with especially with the very slow progress that CCS has made recently, also in Europe. In other countries or in other places, CCS certainly plays a much larger role, but there may also be larger needs for baseload generation. Now, maybe from a system perspective, the two may seem to be counterintuitive, but then there are various different ways how you can also run CCS flexibly. For instance, if you split out the CO2 before, you can store the gas and you can burn it at a different time. So you can actually include some flexibility in CCS with power generation as well.
Sure. Trude, you had some additional
Yeah,
comments?
I think this is about the time frame as well. So if you are thinking into the future that you will produce hydrogen from natural gas and then separate the CO2 and do CCS, that is the future perspective. How far into the future, I cannot tell you, but I'm sure we do see that Statoil, for instance, is really looking into it. And that's not because they're going to lose money. So I think we have to kind of be a bit more ahead of, not just look at the current economics and the current way of doing businesses. This is about the future, and we have to be brave and think that we want to make a difference, a change.
Nisha, you had someone in the
Another
audience.
question from the audience. Ready? Here we go.
Thank you very much. This is a question to the hydrogen guy. Yeah. We have talked a lot about end-user efficiency, and I've learned that hydrogen vehicles that use fuel cells have about a third of the efficiency of a battery electric powered vehicle. And it has been talks about using excess power from wind power parks to produce hydrogen, and then use that hydrogen to power fuel cell vehicles. Do you see a future where we can use electricity to produce hydrogen and then use that hydrogen in fuel cell vehicles? Or is that not efficient? Because battery-powered electric vehicles have about 90% efficiency, and fuel cell hydrogen vehicles about a 30% efficiency. Thank you.
So your question is about the improvement of efficiency of fuel cells? That's your question?
My question is, do you see a possibility for personal vehicles using hydrogen, and that hydrogen being produced from electricity, because it has a low efficiency compared to battery electric vehicles, so taxis and personal vehicles and so on?
Okay. Now, I understand the key, I would say, value of hydrogen. It's an energy storage. It's converting. I would say one of the value chain is converting electricity. Okay, you are going to produce hydrogen to store this electricity and to reuse this electricity into the fuel cell electrical vehicle. So it's really a question of how much energy, how much electricity you can have on your boat, on your train, on your trucks. And it's really, the challenge is more on this storability and the high scale that you can reach with hydrogen. That's, I think.
It's about storage also. So Volker.
Can you hear me?
Yep.
I had one additional question to you, Johannes. I was a bit struck by the very conservative numbers you showed for the building sector and the potential to reduce natural gas consumption there. I mean, I totally agree that European building stock is to a large degree existing, but I mean, you know as well as I do that retrofit technology is in principle available to bring down energy consumption of buildings, of existing building stock, 80 to 90%. Obviously, this is not applicable to all buildings, historical buildings for sure. This is more difficult, but I was still wondering why you. I mean, the numbers that I saw was in the range of 10% until 2040 in terms of reducing the natural gas consumption in buildings. Usually retrofits aren't cheap, but if you do them in the renovation cycle, so every now and then you have to do this with your building in any case, the costs come considerably down, and I mean, it's still 22 years until 2040, so I suppose that a large fraction of the building stock would need some intervention on that time scale.
Yeah, I think what I obviously didn't say in the short time that I had was that there are also countering trends. So you can't say that the 10 to 15% that you've seen in terms of decline in gas use in households is only due to efficiency or something. There are trends that also increase the fundamentals of gas use in households in this scenario. For example, growing floor space. And also there is a shift from oil heating, for example, in Germany, towards gas heating. And there is also a shift from coal heating, especially in Eastern Europe, towards gas. So that's these are sort of shall I say bullish trends for gas in buildings that counter some of the effects from efficiency improvements that you saw in the total numbers for gas.
Okay, thank you very much. This finish up this session, and I want to thank the great panel we have had here for giving good presentations and good answers to most of the questions. And most of the questions. Very good. And then the expert group, of course, and the audience. Thank you very much, and see you back here in some minutes.